Hello everyone, let us solve 5 questions of the day. And day we are taking 26th of September. First question is assertion reason question. Assertion is a double convex air bubble is formed within a glass slab. The air bubble behaves as a converging lens. So first we have to check whether the assertion is true or not. So I'm drawing here a glass slab. So this is glass slab and there is one air bubble formed inside this, which is convex in nature. So this, it means here medium of this lens I am forming here, this is air. Now using this formula, lens maker's formula, this is lens refractive index, medium refractive index 1 over r1 minus 1 by r2. Now you see convex lens, for convex lens this term becomes positive, and here we have to check whether this term is also positive or not. Now you see lens refractive index is less, that is air, optical density of air is less than the optical density of the glass. So here lens refractive index would be less than refractive index of the medium here is glass. So this whole term would become less than 1, and 1 is being subtracted from a term which is less than 1. So this bracket would become negative. So here f would become negative and the lens will behave as diverging lens. Now it is convex in shape or nature, but because the lens medium is having less refractive index as compared to the medium in which it is placed, so its behavior would become opposite. So this is converging in air. Any glass lens is converging in air, but if it is placed in a medium whose refractive index is more than the refractive index of the lens, then its behavior would be reversed. Now, so here assertion is wrong. Now let us check the reason. Reason is refractive index of the glass is more than the refractive index of air. Refractive index of glass is more than refractive index of air. This is correct. So here we can write assertion is wrong and reason is true. Second question is question number 2. What happens if the focal length of a convex lens, what happens to the focal length of a convex lens when it is immersed in water? Refractive index of the material of the lens is greater than that of water. Okay, now let us consider this is a convex lens and it is in air. When it is in air, let us consider its focal length is FA. Now using lens maker's formula, it would be, this is lens, refractive index of lens, refractive index of air minus 1 over r1 minus 1 by r2. So this is the focal length of the lens in air. Now when it is placed in water, we will check what is going to happen with this. So lens refractive index is same, but the medium is going to be changed here. So here we would substitute refractive index of water minus 1 over r1 minus 1 by r2. So main thing you see here, only one term is going to get changed. Now refractive index with respect to refractive index of lens with respect to air, here it is refractive index of lens with respect to water. Now you see lens is being compared with air, here lens is being compared with water. Now you see water refractive index is more than air, so this whole term would be decreased. So when this is decreasing, as this is inversely proportional to focal length of water, as this term is decreasing, so this term would get increased. So focal length of the lens in water will increase. So whatever the focal length it is having in air, it would get increased in water. Third question is, a sphere of glass 1.5 refractive index is 20 centimeter in diameter. Okay, a parallel beam enters it from one side, where will it get focused on the other side? It is not lens here, it is glass. A sphere of glass. Here it is a sphere. This is question number 3. And refractive index of this glass is given as 1.5, and diameter here is 20 centimeter. A parallel beam of light enters it from one side. Where will it get focused on the other side? Now here a parallel beam of light is going to get incident on this. Center of curvature is here. I'm writing C here. Now we'll see where this parallel beam of light is giving us the image. So for this surface, now this is surface number 1 and this is surface number 2, as we have generally done in all the derivations in case of lens. So let us check if the image is being formed inside the mirror, then final position of the image would be written as it is. But if it is outside the sphere, then we have to see the contribution of surface number 2 also. Now let us first check what is the position of the image. So you see, as these rays, they are coming from infinity being parallel, so you would write u as infinity, v we have to find out, and radius of curvature here is 10 centimeter. As it is in the direction of the incident ray, this would be positive. This radius of curvature is 10 centimeter. Here if it is in the air, so refractive index of air is 1 and refractive index of the glass is 1.5. So using the formula for the refraction through spherical surface, we can write mu a over minus u plus mu glass over v is equal to mu glass minus mu air over r. So mu 2, mu 1, in terms of mu 1, mu 2, we have written the formula, but now I have written the formula in terms of mu glass and mu air. Now this is infinity, so mu air over infinity minus infinity plus mu g is 1.5, v we have to find out, v is the image distance. This is mu glass 1.5 minus 1 over r. R here is 10. Now little simplification will give us the value of v. This term would become 0. 1 over something, it is infinity in the denominator, so this term would become 0, and here we would left with 1.5 over v is equal to 0.5 over 10. So cross multiplying 0.5, v is equal to 1.5 into 10 is 15. So v here is 15 over 0.5. So we just remove the point by putting 0 here. This would become 30 centimeter. Okay, so this is the image formation by the first surface of the sphere. Now this, you see, this is 20 and image is being formed at 30 centimeter. It means if the second surface is not there, we would get the image somewhere here 30 centimeter. So these rays are going to get focused at 30 centimeter if second surface is not there, but second surface is there, so we have to show the refraction here also. Now you see here the incident ray is going from denser to rarer medium, so it would bend away from the normal, and these rays are going to meet here at this point, which is nearer to the surface number 2. Now we have to check the final position of the image. This position I want to calculate, means when it is, these rays are going to get refracted through the second surface, then where the image is being formed. Now you see these rays, they are behaving as the incident ray for surface number 2, means all the incident rays, they come from the object, but here this image formation is here at 20 centimeter from the surface number 2, and this is 10 centimeter from surface number 2. Now because this from here till here, this distance is 30 and 20 is a diameter. So from surface number 2, this distance is only 10 centimeter. So you see, as incident rays, they come from the object, and this image which is formed by the surface number 1, this would behave as the object for surface number 2. So here this particular point would behave as a virtual object for the surface number 2, and u would be 10 centimeter, and incident ray, as incident rays are in this direction, and you have to go in this direction to measure the distance of u. So virtual object, so here u is positive. V we have to find out for surface number 2, and radius of curvature, here you have to go from here till here. So radius of curvature would be negative. So r would here be negative, minus. So now we have to write the equation for surface number 2. We can write the formula for surface number 2 by just interchanging the variables, these two variables, and as here for this particular surface, incident ray here is lying in the denser medium and the image is being formed in the rarer medium. So how I can write here? I can write, it was initially mu1 over u, so I can write here mu2. Mu2 here is a mu glass over u, and then plus, it was mu2 over v, but now it is mu1 over v, that is mu air over v is equal to, here you would get mu air minus mu glass over r. So substituting the values, it would be minus 1.5 over u here is 10, we have written u as 10, and v we have to find, mu air is 1 over v, mu air is 1 minus 1.5 over r, r here is minus 10, negative minus 10. So what we would get, minus 1.5 over 10 plus 1 over v is equal to 0.5 over minus 10. So this minus sign would be cancelled. So 1 over v is equal to 0.5 over 10 plus, I'm taking this to this side, 1.5 over 10. So we would get 10 as LCM, 0.5 plus 1.5, 2 over 10. 1.5 plus 0.5 is 2. So 1 over v is 2 by 10, 5. Taking reciprocals, v is 5 centimeter. So here it means this is final image of the object after refraction through spherical surface. Somewhere here we would get the image which is at a distance of 5 centimeter from surface number 2 or 25 centimeter from the surface number 1. Now next question is question number 4. It is, explain with reason how the power of diverging lens, here diverging lens is given, this focal length is negative when it is placed in air. Diverging lens changes when it is kept in a medium of refractive index greater than that of the lens. So here first case is refractive index of the medium is greater than the refractive index of the lens. So here we have to use lens maker's formula, 1 over f is equal to mu lens over mu m minus 1 over r1 minus 1 by r2. So you see here it is given that already this f is negative because it is diverging lens. It is in the question itself, it is mentioned that lens is diverging, so f is negative already. So you see here mu l is smaller, mu m is greater, so this whole number would be less than 1. And when you will subtract 1 from a number which is less than 1, so this whole bracket would become negative. So this negative would be cancelled with this negative and f will become positive. So here the lens will behave as converging lens. But here we have to find out, question number 4, how the power of the diverging lens changes. So here power would become positive as the focal length is becoming positive. We know that power is 1 over f. So power will become positive, means the rays will get converged. And now the second part of this question is, incident red light is replaced by violet light. Fourth, B part. Now red light is replaced with violet light. Now how this power? So power would be predicted if we are able to give focal length, how the focal length is going to change when we are changing the red light with the violet light. Now you see, in the dispersion case, we know that violet color is at the bottom and this red color is here, and we get the Vibgyor pattern. Now you see, violet color is bending to the maximum level, so maximum refraction is taking place for the violet color, and for the red color least refraction is taking place. Or in other words, I can say that refractive index for violet color is more, refractive index for the red color is less. Now here, if I'm having this lens, converging lens, but here as diverging lens is given, so I would make diverging lens. I'm making diverging lens when parallel beam of light falls on it. So here they would appear to come from this point. So this is the focal length. Now when red color is replaced by violet, then refraction would be more. So more bending would take place and the rays would be appearing to come from this point. Now you see here the focal length would be decreased. So more bending for violet light or focal length will decrease. As focal length is 1 over f is equal to power, if it is decreasing, power will get increased. Power will be increased. Now last question, question number 5. Question number 5 is, a ray PQ is incident. This diagram is there. A ray PQ is incident on the refractive phase BA is refracted in the prism BAC as shown in the figure. It emerges from the other refracting phase AC as RS such that AQ is equal to AR. So here some conditions are given. This is a prism ABC, and here the prism is angle is also given, that is 60 degree. Angle A is 60 degree. One ray of light is falling here. Incident ray of light is PQ. It get refracted here, and RS is the emergent ray. And when this is increased in this extended in this direction, now as per the question, AQ is equal to AR. Here AQ and AR, they are equal. If the angle of the prism is 60 degree and mu is of the material of the prism is 1.5, then find the angle theta. So this angle theta we have to find out. Now you see this theta is what? Theta is the angle between the incident ray and the emergent ray. Theta is here, it is the angle of deviation. And this angle of deviation we have to find under the conditions which are given. Now you see here AQ is equal to AR. So these two angles would be same. If these two angles are same, means if this is 60, both of them they have to be 60. And in this particular case also, these two angles are 60, 60. Now you see these corresponding angles are equal, then it means this QR is parallel to BC. So we can make out this QR is parallel to BC. It means this is a condition of minimum angle of deviation. Condition is of minimum deviation. So theta here is delta m, and we have to find out this particular theta. This we need to find out. Now as we know that refractive index is sine of a plus delta m by 2 over sine of a by 2. Now let us substitute all the values. This is 1.5, sine of a is 60 plus delta m by 2, here sine of 60 by 2. So this would be 1.5, sine 60 over 2 would become sine 30 here. Here I am having sine 60 plus delta m by 2, and this is sine 30. Sine 30 is 1 by 2, so you would get 1 by 2 here. I am writing 1.5 into 1 by 2. So this is sine of 60 plus delta m by 2. Now we can use the trick. If I'm writing sine here also, we can make the simple comparison without using trigonometric table. So this is 1.5. I can write this as 3 by 2, and 1 2 is already there. And this side we have sine of 60 plus delta m by 2. Now you see how we can write this. This can be written as root 3 by 2 whole square sine of 60 plus delta m by 2. Here you would get sine square. So now let us try to solve it in another way. From here only we can write 1.5 over 2. It would become 0.75, and it is sine 60 plus delta m by 2, 0.75. This is this value is for sine of 48.6 approx, 48.6 degrees, and here it is sine of 60 plus delta m by 2. So making comparison, 60 plus delta m by 2 is 48.6. So delta m would be 48.6 into 2 minus 60. So here we would get 97.2 minus 60, that is 37.2 degree approx. So this would be the angle of minimum deviation here, angle of deviation, that is theta. So here theta is 37.2 degree. So that's all for the 5 questions. Thank you.